Let's take a look at trying to find the direction of a vector. In this case, we'll be given the components. And the first thing you want to do is kind of do a quick sketch of where the vector would be. So you don't need a fancy graphically drawn set of axes, but if it's in the first quadrant, you'd want to show the first quadrant, or second quadrant if it's there, third, and fourth. And so locating its quadrant is key to getting the answer right. In this case, I have vector A, which has an x component of 5 and a y component of 8, and they're both positive, so we know it's in the first quadrant. And then just a quick sketch. I'm not going to, even though I have graph paper here, I'm not going to measure it out. I just see the x component is less than the y component, so maybe it's about here, maybe the y component's about here, and so the vector would look like this, closer to the y-axis. And I want to solve for angle theta. In this case, indicate what angle you're solving for. So I'm solving for this angle, so I should expect it to be greater than 45 degrees. And since I have the opposite and adjacent sides here, that's 8, and this is 5, we would use tangent theta. So tangent theta is the opposite over the adjacent, and so theta is an inverse tangent of the opposite side, 8, over the adjacent side, 5, and we get 58 degrees, which agreed with my prediction, so nothing too tough here. Let's look at another one. So now vector B, and let's erase here. And so I have now 9 in the x and 4 in the y, so this one's going to have a bigger x component than a y component. So it's going to come roughly something out here. And again, you could be a little more careful in your measurements, but that is not key. I just want to show you how if you sketch it ahead of time, you're more likely to catch mistakes. But so far, these are kind of easy. And so I know this side is 4, and this side is 9. And if I want this angle, I can again use an inverse tangent. And it's opposite, so 4 is now opposite over 9. And that gives me 24 degrees, which makes sense. It should be less than 45 degrees. It's closer to the x-axis. If you wanted to, you could also figure out what the hypotenuse is and use sine or cosine. In this example, and usually in class, I use inverse tangent, so I'm just going to stick with that. So let's do one a little tougher then. How about if they gave me, oops, forgot to move him there. So we knew that was first quadrant. And so what if they gave me a vector C, and now it's 44 in the x and negative 62 in the y. And so what quadrant would that be in? Positive x, negative y, that's got to be down here. And so my direction, my final answer should reflect what quadrant it's in. And so 44 in the x, so maybe here. The key thing is the y component has a bigger magnitude. And so the vector is going to look something like that. So again, just a quick sketch showing roughly where it is. And if I want to figure out this angle, I have opposite that is negative 62. And adjacent to that is 44. And so we can do an inverse tangent of the opposite, negative 62, over the adjacent, 44. And that gives me negative 55.6 degrees. We want to be exact here. And so that makes sense that it's bigger than 45. The minus sign, my calculator says that. It says negative 45. And so for an angle measured counterclockwise from the plus x-axis, minus means it's going clockwise. And so if you entered this in WebAssign, you get it correct if you indicated this drawing. Somebody else might just say, what if I add 360 to this? That comes out to 305.4 degrees. That's the same angle measured counterclockwise from the plus x-axis. So that would be that angle there. and they're the same thing as long as you know what you're doing. Let's take a look at another one, vector D. And vector D has a negative x component and a positive y component. So where will that one be? Second quadrant. And so here's the x and the y. And so somewhere around there, I think I measured, since it's, whoops, let's do this a little differently. A little tricky to draw here. I don't know why that's so tough, but the whole idea is you can draw a really crude sketch and still get it right. So it's definitely a really crude sketch there. And so negative 0.3 is here, and 0.6 is here. And if I do inverse tangent, opposite over the adjacent, my calculator now tells me that is negative 63.4. So if I enter that in WebAssign, I get it wrong. Negative 63.4 would be down here, 180 degrees off. And so do a quadrant check. The minus is in the x component, positive y component. That's the second quadrant where I have negative x and positive y. And so I have to add 180 if I do it this way, and I get the answer we want, 116.6 degrees. So that is this angle. And so if this was a WebAssign question, you would get it right by putting in 116.6. Somebody else might say, well, forget all this minus and plus stuff. I'm just going to figure out what this angle is. And so 0.6 is opposites, and 0.3 is adjacent. They wouldn't put the minus sign in. They just say, hey, theta is the inverse tangent of 0.6 over 0.3, opposite over adjacent, not y over x, but opposite over adjacent. Happens to be y over x here. And they'd say, oh, that's 26.6 degrees. And so that makes sense. No, it doesn't make sense, because that comes out to 63.4. That's coming up. And so that makes sense because it's, notice how I caught that error. I did that on purpose. Because we know this angle has to be greater than 45 degrees. So now that they know this angle is 63.4, to enter it in WebAssign, you could subtract it from 180 and get this angle. So 180 minus 63.4 is 116.6. Somebody else might say, hey, I'm going to get this angle, call it phi. And so here in this case, opposite phi is 0.3, and adjacent to phi is 0.6. And so tangent inverse, so now 0.3 is opposite, 0.6 is adjacent, and now I get the 26.6 degree angle. And so they'd say, okay, I know this is 26.6. WebAssign wants this, or on my quizzes or tests, the angle measured counterclockwise from the plus x-axis. So now I can see easily with my sketch I need to add 90, and that also gives me 116.6. And so a sketch makes it real clear what you're up to. You know how to do this, but if you just punch this stuff into your calculator and you get negative 63.4 and you believe your calculator, you're going to get things wrong. Your calculator lies to you if you're in the second quadrant. So let's look at one more here. So now I have vector E, a negative x component, and a negative y. So we know that is in the third quadrant. And so the x is a little bit less than the y. So something like this. And so I know it should, the angle I get should put it closer to the y-axis than the x-axis. And again, if you just put it in your calculator and do an inverse tangent, we have opposite, there's theta. Opposite theta is the negative 220, and adjacent negative 150. And so your calculator, when you use inverse tangent, doesn't see these two minus signs. So it just tells you, oh, that's 55.7 degrees. And so it's putting you up here, 55.7. You're really all the way here. So if you add 180, you get the right answer, which would be 235.7. So if you put that in WebAssign, you get it. Again, other people might do something different. If you tried to figure out this angle, phi, now opposite of phi is 150, and adjacent is 220. And so if you did that, tangent negative 1 of 150 over 220, forgetting about the minus sign since they're just going to cancel anyway, that gives me 34.3 degrees. So what do I do with this? Well, you could subtract it from 270, right? I know this angle, and I want the angle all the way to here. And so 270 minus 34.3 gives me minus 235.7 degrees. You could also add 90 to it and make it a negative angle, and that would be negative 90 plus 34.3. And so those are different ways of doing it using an inverse tangent. Turns out there's another way to do it, and so stay tuned for that. So I know some of you were disturbed to hear that your beloved calculator lies to you, but it turns out there's a way to get it to tell you the truth when coming up with the direction of a vector. So let's look at these last two examples that we did. We had vector D, and vector D was negative 0.3 in the I and 0.6 in the J. So what is the direction of that? Well, it turns out your calculator has a function on it that will convert this to polar coordinates. Think of this as rectangular coordinates, negative 0.3, 0.6, and again a quick sketch. And so it's got a negative x component, positive y closer to the y-axis, so something like this. And so on your calculator there's a angle function. Now if you don't have this exact calculator, it'll be something similar. You can look up in your manual or online how to convert from rectangular coordinates to polar coordinates or vice versa, which also is kind of handy. And so you can see the angle function here. I have to reach by pressing the second. There you go, second angle. After I turn it on. And then there's all these options here. And if we scroll down, this first option, number 5, says R to PR. That means rectangular to polar radius. If I want the direction, I want rectangular to polar angle. So I hit enter. And now I put in my two coordinates, negative, not minus, but the negative sign, right? 0.3, then comma. Yes, there's a comma button on the calculator. And then 0.6. Then I hit enter, and it tells me 116.6. And if you look back in the video, that was our answer. And that is this angle, and that's the one that WebAssign's happy with. I would use this to check yourself, make sure you know how this works and how you got this, and that you could do it if your calculator was not around. But it's on your calculator, it's handy to use. So let's do vector E. And so vector E was negative 150 in the I or x direction and negative 220 in the J. So notice I picked one from the second quadrant, and now this one's in the third quadrant, something like that, bigger y component in magnitude than x component. And so we go to second angle, and we go down to option 6, hit enter, and so now negative 150, comma, negative 220, enter, and it says negative 124.3. And so that is not what we got when we did it before. We got this angle, which was 235.7. Whoops, it's off. 235.7 degrees. That's what we got before. This angle, because of the negative here, means I'm going in this direction, and so that's negative 124.3. If you add 360 to it, you get 235.7. But WebAssign would take that. That would be correct. I don't usually put negative angles once they get greater than 90, but it does give you the answer, and it's pretty cool. Can you write on your TI screen like I can? Pretty cool. So give that a try. Find the angle button. Try those other examples out. Try it on the homework. But again, if you don't know how to do it on your own, you're going to have trouble. I'm showing this as a way to check yourself and to learn more about how to use your calculator.